Hello everyone, it's September 25th. Alright, yesterday I forgot to turn on the mic, so there was no sound. Stupid, but that's alright. Alright, remove duplicate letters. Given a string S, remove duplicate letters so that every letter appears once and only once. Must make sure your result is the smallest in lexicographically order among all possible. So I just sort it, right? Yeah. We sorted and 2 pointers. So yesterday we know how to turn, no, not this one, how to turn strings into char array. So we're gonna say char array C equals S dot to char array, and then we do arrays sort C, okay, and then we say int I equal to 0 and int j equal to 0, 2 pointers. Then we're gonna go through this array. We're gonna say is if they're the same. So basically here's the kind of what I'm thinking, right? I have a char array. All right, I is here, j is here. If they're the same, j will always move forward, right? J will always move forward. But if they're not the same, right? If they're the same, hold on. What do you want? I want, if they're the same, then I move here. So I'll make sure I is the position that causes the repeats, right? Let's say this will be A, B, B, C, C, right? So we say I, J. If they're the same, then no, it's not. I think I and J push both on here, right? And then we say J. If they're not the same, then I swap. Not swap, I move it here, and then move J forward. If they are the same, this is the same, then we move forward. They're not the same, then, so if they, hold on. So every time I swap, I point into the next one. Okay, so yeah. So IJ is starting here. If J is always, if it's not the same, then I move myself to I's position and then J will move forward, right? And every time I do this, I'll move forward as well. If these are the same, J move forward, but I doesn't change. Not the same, change to this, I and then J. The same, J move forward and then done. Okay, so I think this, so I keep I, now both will be starting on one position. For int J equal to 1, smaller than C dot length, J plus plus, okay. I say if Cj is equal to Cj minus 1, right? If they're equal, then nothing changes. So we'll do if they're not equal. If they're not equal, then we say Ci shall equal to Cj, all right? Ci equal to Cj, and then I plus plus. Oh, we can do this I plus plus, and then we'll return. How do we get string from char array? Java build string from char array. the value of, what if I only want a certain number, a subarray from subarray? Ooh, nice. Offset and the length. So I think I can say return new string C, offset will be 0, right? Count. Well, I is pointing to the 1. That's, so I should be I, right? Okay. What do you think? Give this a shot. All right. Oh, you cannot sort it. They have to keep the same order. Ah, you have to keep the same order. So you're only allowed to remove. Wow. Okay, so this is not right. You're only allowed to remove because you remove, and then you can remove D. C, D, and then B. All right, that's a different problem. Okay, that's a different problem. All right, let's do this one more time. So we have C, B, A, C, D, C, B, C, right? I mean, we can, like set, sort, so we kind of know who's in there, right? Who's in there. So as we go through, so we need to remove, so the remainder is the smallest. Then how do we know that we have enough remaining? Well, what if we, I don't know, get this C at position 0, right? And then, well, actually, we should do A, B, C, and D, right? A is 0, 1, 2. A at position 2. That's it. B as 0, 1. 0, 1, 2, 3, 4, 5, 6. D 0, 1, 2, 3, 4. And C 0, 1, 2, 3, 4, 5, 6, 7. Right? So we can do that, right? And we can get into a sorted order, right? We can get into a sorted order, and then we create an array of size 4 because there's only 4. Now we go A, right? A has 2, and we should always get a little bit, the more to the left, the better, right? If it's only, the more to the left, that means we have more chance to be small. So A has to be, but where do you put A? Where do you put A? Interesting. So A has to be by itself, right? Then we need to know if there are enough BCD, like the remainder, are they all larger? Do we all have something bigger than this? Do we? Well, in this case we do, right? In this case we do. How do we determine that? So we know A is at the second position, right? How about this? We do C, okay? Now we'll have B, right? And then B is smaller than C. So if there is a C larger than B, then we good. Okay, so we say, okay, we have a C bigger than B, so I can replace it to be B, right? Now come in A. Now for A, I need to know if there's anything bigger than A. Is there anything, another B in the future? Then there is. So I replace this. Now we have A, right? Now we have A. Now we have a second C. Okay, so we just put it there. Now we have a D. We put it there. Now we have another C. Well, C, we use it already, so I don't use it. Now we have a B. Now B is smaller than D. Now we need to ask if there's a D after B. If there is, I can replace it, right? There's not, because D is by itself. So there's no more D, so we have to keep this one here. But what about the ones in front? Yeah, so this, then we have to go for this one, right? To see, is there a because if there's another C, I can, oh no, you cannot. You can only replace this one. You cannot replace the one in front. Because if you replace the one in front, now this B happens before D. So we can only check this, right? If this is bigger, if this is smaller, then you just add it. Is that right? Well, yeah, because if this one is bigger than this, right? If the current one is bigger than the previous, it's always better to keep the previous this way, right? Your current add, because you don't want to swap it. You swap it, become bigger. So you only want to swap or want to replace if this, okay. And then that's it. We're done. 4, right? Okay, now the question is, how do we tell if there's something bigger? Well, I can just, let's say we do, we record the largest, okay? We record the largest index. So whenever I hit something, right, I start with C, now I have a B, right? B current position, and I say, oh, C has a bigger one, so okay, we just do B, right? And A has a bigger one, so we do A, right? And now we have a C. C is bigger, so we don't want to put in, so C put in here, and D is bigger, so we put in here, right? And then we probably should have another set, right? Every time I put something here, we do the set. But I think set probably take a little longer, so we can just do, you know, an array, right? We can do an array. So Java, how do we get? Oh, I think char can do arithmetic. Yes, I think char can do arithmetic. Hold on, I think I have this Java. Java something. What's the repo for Java? I just do this online. JShell. Right, I just need to say char A equal to A. A minus 65, right? No. 97. Hey, there we go. So yeah, we can use that. So let's try it. All right, this is now we don't have to turn it into a char array. No, we don't. All we need to do now is to have a So we say int, right? Max position shall be new int 26. Okay, and then int visited new int 26. Perfect. For char c of s dot to char array. I don't know. And we say max position c minus 97 equals, oh no, you need a position. Okay, and we say max position s dot char at I equal to I. Okay, and then we say int res equal to new int 26. Well, it's the most is 26, right? And then we say int I equal to 0. We go to I again. Then we'll go through for int I equal to 0. Right, I smaller than star length. I plus plus. Let's call this j. Okay. Not really. I should do some 1. Int j is also 1. And we shall say res 0 go to s dot char at 0. First one, just put in there. Okay. So now I'm in the current one, so I need to compare to the previous one, right? Then we say if s dot char at I is larger than and also visited, right? So visited visited okay, visited s dot char at 0 minus 97, right, equal to 1. Okay, so set them up, j setup. Now we say if it's larger than res j minus 1, then res j equal to s dot char at I, and visited s dot char at I minus 97 is equal to 0. Right, not visited, and we need to put it in there, and a visited s dot char at I minus 97 equal to 1. Okay, and we'll increment j. Okay. Oh, what's this? Multiple occurrence. All right, so let's char current equal to s dot char at I int current index shall equal to current minus 97. You happy? All right, so this will be current, and this will be current index. Okay. Else if visited current index is 0. Right, so this is smaller. Current is smaller. Else if current is smaller. Right, current is smaller, then I need to say if I have another one bigger than me. Right? So we can say current is smaller than res j minus 1. Need to check if res j minus 1 will appear again later. So how do we check? We say if this equal to 0 and smaller than this. Ooh, hold a second. Hold a second. You know what? I want to redo this. I think the first check should be if visited current index is equal to 0. Okay? Then we check if current is, so the only case that we don't put it, if current is smaller than res j minus 1. Okay, current less than 1 and something, then we will continue. Right, otherwise we'll always do this. Then we can remove all this. So what is this condition? If current is smaller than the previous one and the previous one does not occur again, which means I, right, is larger than max position res j minus 1. Right, so this, although current is smaller than res j minus 1, but res j minus 1 does not appear again. Right, it does not appear again. So in that case, no, but appears again. Right, but it appears again. Appears again. Wait, hold a second. Current is smaller, right? And I is smaller. Then we'll swap. What the hell are you doing? Current is smaller and, right, and appears again later. Replace this with current. So how do we replace? We say, first of all, I need to go visited. Okay, visited res j minus 1 equal to 0 because we no longer visit, and then we'll say res j minus 1 will equal to current. Right, so we replace it and visited. That's not right. Minus 97. Visited current index will equal to 1 because I visited the current one, and then j doesn't change. Then we move on. Okay, then we move on. Okay, else. So else is either current is larger than that, right? current is larger, oh shoot, current is larger than the previous, so we do that, or current is smaller but there's the previous one don't appear again, so I is larger equal to, yeah, so when that happens we will do that, just add it to the current position and do that. But in both cases, right, in both cases, so the current is not visited, right, the current is not visited, so no matter what we will visit the current one, right, we'll visit the current one. So this can put on the outside, so we will visit the current one no matter what. Right, we'll visit the current one no matter what. Either we replace the previous one, or I don't replace the previous one and I will visit it again. And if it's not, then we just let it go. So we keep going, keep going, keep going. Now in that case, I wonder whether we need to do this, the current index. I think I'm only use it once. No, use it 2 times. Okay. So now when we're done, right? When we're done, then we can return, say new string, res start point is 0, count as a j. Okay, let's try this one. Minus 97. You just kept forgetting that, huh? Alright, how about we do this? So char current, right? Char pre equal to res j minus 1, okay? And provided int. Oh my goodness. This is a char array. Int pre-index. Pre minus 97. Alright, and then now we like this. These can be pre, and this is actually pre-index, right? This I cannot change. This is also pre-index. Okay, so let's try it again. Yeah, I don't like it. Just do this. ACDB BAC. Oh, that's bonkers. How can we get BAC? We go B, C, A. I replace one. Oh, I need to keep replacing it. I see. But the first time I cannot replace, I'll go down. Okay, that's fine. So this shall be a while loop, right? While current. Oh, damn. All right, let's put them outside. Char current, char pre, int current index, int pre-index. All right. So current I can get these has to be changed. Hold on, these have to change. So these two I can get at the current moment, no problem. and then while, and then, oof, is a while loop. So actually yeah, it has to be, and j has to be larger than 1, because I cannot go down to 0, right? If j go down to 0, so while j is larger equal to 1, and current is smaller than res j minus 1, and I is smaller than, we have to redo this, j minus 1 minus 97, right? While this is true, I replace. Oh, but there is always something again in the future. But what if in the future it's... It doesn't matter. Doesn't matter, because we need to guarantee the smallest is first. Okay, so we do that. We say visited. Unfortunately, we have to go this, right? So this is equal to 0, and res this equal to current, correct, and then j minus minus, right? Go back up, we try it again. If it's good, we redo it, j minus minus, all the way, right? All the way until a point where we get out. Okay, until a point where we get out. Now, when we get out, it could be, something it fails. It could be many things. Then we don't do this one here, right? We don't do it here. We just remove it, try the previous one, remove it, try the previous one until j is equal to 1, right? And if it's still this, then j becomes 0, right? J becomes 0, or some fails. Now it depends on where j is, right? When it gets out, depends on where j is. I think no matter what, you always do just put at a j position, because if this one fails, like current is larger than, then you add a j. So you always do it at the j position. Now this one looks good. Okay, try it again. Man, these are good test cases. I actually have one more. Let's do one more. Let's get BCACB. How about that? Huh? BCACB. Okay. Let me change this one. Although current is current is smaller than this and appear again later. Right. All right. Are we there? Let me run a few more. Like this, right? Let's say DCBA, right? Just go down. ABCD, go up. What else? Yeah. Let's do this one. All right, let's see. Oh, yeah, there's one more test case I can get. Let's do one more. Let's do one more, which is my favorite. It's called smashing the keyboard. And if smashing the keyboard works, most likely it's gonna work. Yep, I think this probably is right. So I've done it 2 times in the past. It's pretty good, huh? 2020, 2022, 2023. So we can look at the previous solution. I think this is the right solution. This is definitely the right solution. 316. Yeah, I thought it was the other problem initially and then did it wrong. What do we call this? This is what's this type of method called? You build and then you retrack. Damn, it's gotta be a name. I forgot. What's the name of this method? Like a monotonic, right? Like a monotonic stack, monotonic array. Yeah, let's call it that. It's similar to a monotonic array. I'd call it stack, right? For each new char in S, we check the already built string, right? And see if the end of that string is smaller or bigger than the current char. If the current char is bigger and hold on, for each new char that has not been incorporated, okay, we check if the current char is bigger, we appended it, right? We append it because we can't do anything about it, right? We append it because that is the best we can achieve at the moment. If the current char is smaller, then we need to go backwards on the built string and compare, right? And back string for if the current is smaller than the last of the built string, and if the last of the built string will occur again later, we can safely remove pop, right? Pop the end of the built string, right? And continue the check with the second to last char. We keep this check, right? We keep this check until either we run out of a char to check, or a char that is either bigger than the current or does not appear again later, shows up. That is where we place the current char. So in addition, right, to the monotonic stack, we also need to identify the latest occurrence of each char and establish a special way to check whether a char has been incorporated. So overall, this is ON. Okay, so that's that. We are going to move this into hold on, let me cancel this. Wait, hold a second. Okay, so that should be 26. All right, let's check the previous solution. So I have this one. Let's just go all three. Let's see what solution. What's this solution? Monotonic stack. I see the hint. Oh, so I did better than last time, because the last time I did not do monotonic stack. Oh yeah, look at this. This is just one line, right? Python is one line. Here I have multiple lines. I use a set, which is fine. Last encounter of the letter. If letter not in scene, well, stack is the last one, is larger than, and this is larger than, yes. Well, remove. Remove, just like this. We set it to 0. And then we'll append a new one. Oh, the stack is, oh, okay. Like this, right? We append a new one, scene.add, and then, yeah, it's the same idea. Okay, how about this one? Better monotonic stack. Oh, we can directly use stack as scene because the size of stack won't be, okay. We can check whether a letter to be popped has more copies by comparing the current index with hash map. Basically, we compare the index of the letter to be popped with the index of the last occurrence is wrong, and we have to create an extra step for the last encounter to correct. In this method, we simply compare the last occurrence index with the current. If the last occurrence is larger, this is what we do now, but how do you check if it exists? I say, well, stack, that's fine. If letter not in stack, oh, I see. Because it's size 26. But yeah, if I use a stack, I can do that. Like if I use a array list for the stack, I can do that. I think I can do that. But for this one, I set a char array. I don't really think it's possible. Hold a second. Maybe it is possible. Can Java do this? Java array contains. Do I have array contains? It's a list. Can I do array? Probably not. Ugh. Nope. No. I'd rather set up a new one. Yeah, that's not the way to go. But yeah, if you do array list, that's fine. Array list is fine. Yes. Hash map this larger than 1, which is exactly the same as this thing, right? So basically, instead of using a stack, we are simulating a stack on it, which is fine. What's this? Greedy. We always want to pick the smallest letter available so far. Whether such small letter can be picked is contingent on whether the total letters available to pick after choosing the smaller letter match that of the input. If they match, that means picking the smallest letter does not affect the ability to pick any of the other letters. We shall pick it. Otherwise, we cannot pick the smallest letter because picking it means some other letter cannot be picked. In this case, we simply move on to the next smallest letter. So we will do a set, we'll sort it, and we'll say the next s is equal to s dot index. Wait, what? What is this? Oh, I know what this is. This is, wait, are you kidding me? Really? S dot index. This is finding the index. This is to find the index. This is like 10 to the 4th. I'm not sure. What's the runtime on this one? Yeah, this runtime is not really that friendly. Okay, so next S is, dude, you're killing me. This basically to find out, yeah, because this is this, right? We're copying the string, okay? We're copying the string from the current position, which is the smallest, to the end. Then we do a set on it to check if it is equal to the previous one. including the current one, right? If it's equal, that means we can do it, right? That means we can do it. So we do this, and then we will call, oh my god, oh my word, oh. Who thought of this method? Cruel and unusual. I'm not implementing this. All right, that's it. Okay, that's it. We got the right method. Just move on. All right, more JavaScript. Yeah, let's do more JavaScript. Calculator with method chaining. Design a calculator class. The class should provide a mathematical operations of addition, subtraction, multiply, division, exponentiation. Power. Holy crap. It should also allow consecutive operation to be performed. I think you have to return this. The calculator class constructor should accept a number which serves as the initial value of result. Your calculator class should have the following method. Adds the given number to the result. So I probably need to have a result out. Hold on, let me get a JavaScript out. So yeah, so I think we need a let res, right? And then we can say this dot res, no, yeah, equal to value. And then add, we can say, I don't know, this dot res plus equal to value, return this, and subtract from the result this dot res minus equal to value, return this, multiply this dot res multiply equal to value, return this. Wait, hold on, return what? Calculator, add, subtract, get result, divide this dot result. Hold on. Yes, this dot res divide equal to we have to try value except catch error, throw, new error, division by 0 is not allowed, return this. Okay, get result, power, actually I don't know, JavaScript power, script power operator, math.pow. Oh, we can do this, exponentiation. Okay, so we can say this dot res equals to this dot res value, return this, power, get result. Okay, so get result, return this dot res. Is this right? This is not right. Actually, I'm not sure. Do I not? Class constructor. Oh, you just put a name there. Okay, that was wrong. I just put this one there. E. Division by 0 is not allowed. Wait, I have. What the hell? What the hell? Let's see. So we calculator divide. We call divide and calculator divide, right? We say this dot result divide equal to value and catch. There's no error? Dude, you're killing me. Maybe I syntax is throw new error? But I don't even think it gets here. Oh, you are kidding me. It can do that, huh? Wait a second. Let's say a equal to 20. A divided by 0. No way. Oh my goodness. Okay, let a equal to 20. You are kidding me. Has already been used. Okay, let's say b. B divided equal to 0. I hate JavaScript. So it's not a try, it's a if. I'll have to do this one again. Okay, it must be if value is equal to 0. Okay. I remember it's not new error. I think it's just throw error. It should be sufficient. Otherwise, we do this and we return this. That's what I remember. And this is wrong. This is right. Okay. Yep. Yep. That should be it. All right, but that's solving the problem itself is not really, it's not the thing that we should be worried about. This is a value. All right, these are just recap the problem. Method chaining, yeah. Multiple methods in a single statement. That's also why what I learned, because when you do sort, right, arrays.sort, it does it in place, but it also returns the reference to the original array, which really is not the right way to do things, I think, because you're changing it, you're making changes in place, so you should not return anything. But JavaScript does that to facilitate this method chaining stuff. So they kind of put method chaining on a higher priority compared to the other, to like compare the methods to make it make sense. So method chaining is to return this. Yes. Exception handle. Throw. Oh, you can just throw. That's interesting. Okay. Oh. Data processing. DOM manipulation. Yeah, that's... Oh, you can directly. You don't have to. Okay, that's fine. That's good. Oh, you can do this. Nice. Certain operators may not yield the exact result. That's for sure. Uh-huh. Multiple methods in the same line. Okay. Yeah, you can call that. It's like in Scala, right? When you have chaining. Mm-hmm. A special keyword that refers to the context in which the function is called. In the case of method being called on an object, this refers to the object itself. Modify the object's property in the calculator class using this in the add to maintain and manipulate result property for a deeper understanding. Where can a class like be used? Alright. Oh, good. I like it. I like all this. Do we move on? Nah, I don't want to move on. I want to cut it. Yeah, that'll be it. Just no light on the load. All right.